Okay, I'm going to talk a little bit now. This is the ES7 Plate Tectonics Study Guide continued. I'm going to talk a little bit here about types of crust. You've got continental crust, and you've got oceanic crust. Continental crust is thicker and less dense and older than the oceanic crust. The oceanic crust is thinner, more dense, and newer. And the density of the crusts becomes important when there's a tectonic plate collision. If you have continental crust colliding with continental crust, you have folding and faulting that creates a mountain range because their densities are pretty much equal. But in the case that you have one plate that's more dense than another one, you get something called a subduction zone at your tectonic plate boundary. So oceanic crust will slide underneath of continental crust because it's more dense. And this also causes mountains and volcanoes at the boundary. This is also where you'll find an ocean trench. So if you can also have a subduction zone where it's oceanic and oceanic plates colliding. Oceanic and continental can also be a subduction zone. And whichever plate is more dense, even if they're both oceanic, one might be a little more dense, slides underneath. And this is where you'll find ocean trenches at these subduction zones. Need to tell you a little bit about hotspots. So this is like a chain of islands, a chain of volcanic islands, like Hawaii, but maybe not exactly Hawaii. And underneath the oceanic crust, you have magma rising to the surface. And this is called your hotspot. And what's happening is the tectonic plate is moving over the hotspot. The hotspot stays still, and so maybe like 1 million years ago, this volcanic island was over the hotspot. And 2 million years ago, this volcanic island was over the hotspot. And 3 million years ago, this volcanic island was over the hotspot. And 4 million years ago, this volcanic island, which has since been eroded away, and now it's just an underwater seamount or a gyat, that is the oldest thing in my diagram. The newest thing is currently on the hotspot, and that's where you're going to have your active geology. All right, wrapped up in this unit as well is Virginia physiographic provinces. So here's my accurate rendition of the shape of Virginia. You have 5 physiographic provinces of Virginia. And physiographic provinces, that just means like geologic zones, like places where the rocks are unique. So number 1 here is the coastal plain. Number 2 is the Piedmont. Number 3 is the Blue Ridge. Number 4 is the Valley and Ridge. And number 5 is the Appalachian Plateau. And you want to know a few things about each of these provinces. You want to be able to label a map like this, but you also want to know a few things about these provinces. So Valley and Ridge and Appalachian Plateau are made of sedimentary rock. And sedimentary rock always forms at the bottom of a body of water. These provinces, even though they are not currently underwater, were once under an ancient ocean. And so you can find sea critter fossils. So that could be fish, that could be clams, that could be aquatic plants. But things that lived in the sea, you can find their fossils in these regions that are no longer underwater. Appalachian Plateau is also where you'll find coal, an important resource in Virginia. The Valley and Ridge is where you'll find something called karst topography, K-A-R-S-T. Karst topography is where you got limestone underground. Limestone is your sedimentary rock, and limestone's easily eroded by normal rainwater, and over time it creates caves, caverns, and sinkholes. The Blue Ridge Mountains so those are igneous and metamorphic. They were formed by a tectonic plate collision. And because of the rock types, you're not going to find any fossils in the Blue Ridge Mountains. This is also where your tallest peak is in Virginia, Mount Rogers. And this is also where you're going to find the oldest rocks in Virginia, up to 1 billion years old. Piedmont is also igneous and metamorphic. This is the foothills of the Appalachians. Pied means foot in French, mont means mountain. Sometimes this is referred to as the rolling hills of Virginia. And Richmond, many other cities are on this boundary between the Piedmont and coastal plain called the Fall Line. And this is where you find rocky rapids in the various rivers of Virginia. And when they first settled here, the Europeans did, they couldn't bring their boats any further than that, and that's why Richmond ended up where it's at. Coastal plain, also sedimentary rock, but this is the newest. And so you got sedimentary rock and sediment forming. So this is like the mountains are getting eroded, the rivers are carrying the debris down, the weathering and erosion brings the sediment down through the rivers and it gets deposited on the coastal plain. So the coastal plain is constantly being formed still today by the erosion of the Blue Ridge Mountains. Trying to think if there's anything else you really need to know. Oh yeah, the Ring of Fire. So The Ring of Fire is the area surrounding the Pacific Plate. Lots of geologic activity. That means earthquakes and volcanoes. And that includes the west coast of the United States, the west coast of South America, Japan, Indonesia, Alaska. Everything that surrounds the Pacific Ocean is part of the Ring of Fire. I think that's about going to do it for plate tectonics. Thanks for listening. See you later.